Thank you for the gentle introduction. I would like to share my screen. Okay, do you see my screen? Sorry, do you see my screen?
No.
Yes, I see it now.
Okay. Okay. Everybody see the screen at the moment?
Yes, I can see it.
Okay. Okay, I would like to start right now. So thank you a lot for the gentle introduction. So my name is Viet, and right now I'm from Luxembourg, and my friends and colleagues here, they are from France. The project we are working in the last couple of months during the code forward challenge is how to apply knowledge graph to enhance large language model and scientific literature synthesis. So to give a little bit context, because large language model took the world by storm like in 2 years ago, and since then people have tried to find the application of large language model on everything, and also they want to apply the existing technology on large language model to enhance its performance and trustworthiness. So one of such tool is the knowledge graph, and this is the main focus of our work. Okay, so to give you a little bit of what would be on today, this is agenda. We start with the problem description and a solution. Next is our approach, how we conduct the work, and next would be the demo, a small demo of what we have done, and later is some future direction. For that, I would leave it to my colleague to start the first part.
Thank you, Viet. Yes, so first I will present about our problem. About our problem. So for the background, ECMWF has already deployed an online chatbot, so with which we can ask about anything, but especially question about meteorological and weather forecast information. So basically, we give the question, and the chatbot will answer us in text, image, or also code. So the technology behind this chatbot is ChatGPT, so which is a large language model. So large language model usually suffer from hallucination. So next slide, please. Yeah, so normally large language model usually suffer from hallucination and knowledge cutoff. So which means that the answer may not be 100% correct, and the chatbot's knowledge will be limited to some point. So to solve these problems, we can inject more knowledge to the chatbot by using knowledge graph. So next, please. Yeah, so knowledge graph is a structured data storage which contains entity in real life as nodes and the relation between them as edge. So basically, it integrates knowledge into a graph as a storage. So you can see the image in the right. Next, please. Sorry. So for our project this year, the goal is to enhance the chatbots of the ECMWF in two means. So firstly, from the meteorological and weather forecast documents, we will create a knowledge graph based on them. So this knowledge graph will serve as a knowledge base which help the chatbot to reduce hallucination and improve correctness of the answer. So secondly, a small interactive knowledge graph will be generated beside each answer of the chatbot in order to visualize and provide better comprehension of the answer. So that are our two main goals in this project. Next slide, please. Yeah, so now we have several solutions, and the two foremost solution would be one is a large language model graph builder. So it is developed by Neo4j. So Neo4j is a graph and a database technology, and this package is friendly user interface, and store knowledge in cloud. And the second solution is the graph rack developed by Microsoft. So they have no idea of they have the community description on the entity, and they have the description on this entity community to summarize the entity. And but the problem that they are very heavy and they don't have visualization. So now my teammate will discuss about our approach in this project.
Okay, so now we are going to the details of our approach. So first, I'll give you the overview of the whole architecture design, and then we'll go into details into each component in this architecture. So next slide, please. Okay, so first we will have the documents and the knowledge resources, and they are available in the PDF files. And now we need to use a knowledge graph generator to extract, to process these PDF files and extract the knowledge graph or any other necessary information into JSON files. And these JSON files will be uploaded to Neo4j, which is a graph database, as we just mentioned later. So, and this Neo4j database will work with the Python, with a Python backend, which finally interact with the front end that is written in React. Okay. So first, about the knowledge graph generator or knowledge extractions, we first need to process these raw data, which are available in PDFs. So first, our work is to extract the text, the raw text from these PDF files. And while doing so, we have to pay attention to some details. For example, we have tables and figures that are not extractable, but still we have some captions of those figure and tables extracted to the text file. So we have to pay attention to that. And also there are some parts where the text is very repetitive and not useful for the knowledge. For example, the footnote or the or sometimes the headings are not quite enough useful. So we also ignore that in the text files. And from that, when we have the text files, we can use a large language model such as ChatGPT to extract the knowledge graphs and other information such as the text chunk and such as the content, the chunk content and the embeddings, and this will be explained in the next slides. But for now, we now have the knowledge graph, which is included, which includes the entities and relationships, and also the texture. So now in the next slide, please. So now we need a Neo4j to store those data. And Neo4j, as I mentioned, is a graph database. Is very famous for storage of knowledge graphs, and they have some emerging techniques to work with the AI chatbot. So that's why we choose Neo4j for our database framework. So next, my colleague Viet will present to you the rest of our work.
Okay, so to explain more deeply how what we have done, so we start with an example. So for example, here is a sentence we extract from the document. So here's the physical fluxes are archived by the ICMWF model, and from this one we extract two entities. The first one is ICMWF model, and the second is physical fluxes. And these two entities is information is stored in these nodes in the graph database. So first we have the a sentence which is stored in the chunk, and second is the entities that is stored in the entity extracted is going to be stored in the entity nodes. And these two node is linked to each other by the relationship appeared in. Now we have like graph of entities, right? So we need to so we try to cluster this entity together. And so with this clustering step is kind of like to give us a little bit of global view of the document, rather than just process document by text chunk. Right now we can have some level of globalness of the document. So at the moment, I would like to emphasize that we have three types of nodes. The first one is chunks, and the second is entities, and the last one is communities. And all three types of chunks, three type of nodes have embeddings. So this is for facilitating the search later. So now we have information like next we have to find a way to retrieve information. So we start, so when users type their query, their question, from that we also have chat history. We from the local point of view, we're gonna retrieve the relevant entities, and from these relevant entities, we can retrieve the relevant chunks and relevant communities. Chunk have contents and community has some summary. So, and we collect all of the content and summaries and chat history, and we put it into context. And this context want to be used to provide to LLM later. The second type of retrieval mechanism is global retrieval. So we start with user query and chat history, and we search for the most relevant summary. So we attack to the more global view, and this summary gonna be provided as context to LLM. So this retrieval mechanism is greatly inspired by the work of GraphRag of Microsoft. Okay, so right now we have the whole mechanism, and next we have to find a way to visualize this and incorporate in the chatbot. For that, we use to web application. We have backend as a Flash application, front end in form of React application. Okay, so the workflow of the graph would be like this. So first we start with a query, a question from user, and this one gonna start the search process. The search process appear in database, and the database gonna retrieve relevant information from the all the contents and also the graph. And this all the information is returned back to the web interface. And from that, we split out two results. The first one is the answers, and the second is the visualization. So I would like to show a little bit of demo of the web app we have developed. So you can build this web app from our GitHub repository by using the Docker file. So here we can start with the chat. We can start. So right now we only integrate the chat app and ignore the part of constructing graph because it takes some time. So for the sake of time, I just present the result in the chat app. So we can start typing what is the main idea of the document, and it will present first the question for the answer, and the answer is on incorporate all the information in the entity. it can be entity, it can be some community. Maybe have this community here. It's of information of the community, and uh, the text chunk have the information of the text chunk. Chunk here have a contents like that. So all of this information is fed into the LM, so it can have some knowledge relevant to the question and start giving the answer. Okay. So this is still a very early work, and we face a lot of difficulty during the project, and it's also the opportunity to develop later. So the first one is prompt engineering. So to give the instruction for LM to extract information from document is because right now we focus on the ICMWF document, and sometimes it requires some domain expertise on this one to give the fine instruction, and this is not easy to acquire. So to construct a good prompt is difficult. The next is the unpredictability of LMs. So if you give the instruction of LM to do stuff, to extract information, and in a large document that might give that might lead to some unpredictability of the result, and sometimes it's difficult to assess the quality of the extracted data set. And next is because we at the moment we use ChatGPT API, and there's some limit on the number of code to construct the database. So if the database is very long, we cannot accelerate it through multi-thread because the number of code is limited. Okay, and next is the visualization. So as we can see, the visualization is in a very simple form, and we can find a different way and more beautiful way to present a more intuitive and a result for the user. Next, I would present some future direction that we can take. So the first one is they enhance the entity extraction. So as we can see from the prompt engineering, we do not have good prompts. So sometimes the entity return is not very good. Sometimes the entity, they have the same entity, but is written a bit differently, and that is a part that we have to merge these two entities together. Next is how we can enhance the graph in construction. So we might consider using local LM because it doesn't cost much as buying coding API, and we can use multi-thread to accelerate the graph construction. We can extend the local retrieval. So before that we only see the retriever operate on the node level. So it also can operate on the edge level also. So it is another way to retrieve more information from local point of view. And next is to enhance the visualization. Okay, so thank you a lot for your attention. I'm happy to take your questions.